Okay, so remember before last time we learned how to add intervals when the sums are no larger than a seventh. We made a whole video about that. And we also learned to subtract from a seventh using that knowledge, which we found that it was, easier to just think backwards, to do that. We found that it was easier to just think backwards. Okay. Now, in the last video, we realized how we could add to an octave, etc. Here are some examples we covered. And we also learned to subtract from an octave if the interval is small enough. Look at some of the examples we covered. Remember, you can always pause if you think it's necessary. How do you use this knowledge to add any interval or any number of intervals or many of different signs? Interestingly, even if we have restricted ourselves to adding to sums, when we add something, you get a seventh, you get at most a seventh, nothing bigger. And we found out how to add intervals to an octave in the last videos. It sounds restrictive, but we already have all the information we need to add any number of intervals, whatever the signs are. Okay, here's how to do it. First, you're going to separate the positive and negative intervals, and we'll add them separately. Second, we rewrite each member of each group, positive, negative, as a sum of a multiple of an eighth, plus some remainder between a minor second and a seventh. No smaller than a unison. Well, the unison is like 0 in our system. Strictly between a unison and an octave. The remainder has to be strictly between those two. And thirdly, you're going to add the remainders 2 at a time, the way you add numbers normally. And here's how you do it. First, if the sum of 2 remainders is no bigger than a seventh, follow the strong weak interval rules we followed in the before last video. And remember, we've separated the positive and negative, which means that we're treating them all like positive intervals. Each group is a bunch of positive intervals. We'll worry about, when we're done reducing each group to one interval, we'll worry, about adding those together. Otherwise, complete the eighths. The octaves. Gather all the octaves and add them to each other. We'll explain how to complete an eighth very soon. Fourthly, when the positive group and the negative group are each reduced to just one number or less, that means it could be a big number, but one number or less, add what you have left. Isolate an eighth if necessary. If you remember, we did that in the last video. We're going to cover examples, don't worry about that. You won't have to remember all these rules after seeing the examples. It'll be obvious what to do when faced with a sum. You're not going to constantly be saying, did I follow step 1? Did I follow step 2? And now we're going to try to make it a little more clear what we mean by completing the eighth. Imagine we wanted to gather 8. We're just adding numbers normally now. We're not adding intervals. We wanted to gather 8, the number when computing sums, when adding numbers normally. If we are adding 6 plus 5, we can take all of the first number, which is 6, and take what the first number is lacking to be 8, which is 2. You need 2 to make 6, 8. You take that from the second number, which is 5. We only have 3 left for that second number. There's only 3 left. So we get 8 plus 3. And you see 6 plus 5 equals 8 plus 3. Look at the pictures to understand the simple idea of what we're talking about here. And in the same way, if we're adding 7 plus 6 plus 9, we can do the same thing. Get what we're missing from the 7, what the 7 is missing to be 8 from the 6. Take what we have left in the 6 and add that to what we need to get 8 from that. We get 8 plus 6, or 2 times 8 plus 6. This is what we're talking about when we say complete the eighth. And here's another visualization, this time with little squares. We gather 8 blocks each time, rewriting the sum in a way we can handle. Remember, these are not intervals, they're just normal numbers, so our rules for adding intervals will not apply. In order to add 4 plus 5, you can take 4 from the 5. In order to add 4 plus 5, you can take 4 from the 5, since that's what you need to add to 4 to get the 8, in our normal system, of course. And we write the sum as 8 plus 1, 1 being what was left over from 5, In the same way, to compute 7 plus 6, we can take the 1 that is missing from the 7 to get 8 from the 6, and then add 8 plus 5. 5 being what was left over from 6. Okay, now you see those are just illustrations. Remember, those were not intervals. So you see, we just did 4 plus 4 equals 8. You know, in our system, it's a fourth plus a fifth. That is an 8. We're just doing it with normal numbers. Now we're going back to intervals. First, we're going to add a fifth and a sixth. Nothing is larger than an octave. No need to worry about writing any interval as a multiple of an octave plus remainder. So we could straight away think about completing the eighth. What do we need to add to a fifth to get an eighth? Well, a fourth, of course, so we need to decompose a sixth into the fourth plus whatever's left. Since we need to borrow from the eighth, we need to borrow the fourth, you know, from the sixth. But we know how to add all intervals as long as the sum is no larger than a seventh. So we know how to subtract a fourth from a sixth. We get a third. So we know that fifth plus sixth equals fifth plus fourth plus third. You know, the fourth plus third is a sixth, and we needed to separate the fourth because the fifth plus the fourth is an octave. So we get an octave plus a third, and that's easy to compute. It's a tenth. Just apply the rule as if we didn't care about chromaticism because you're dealing with an octave. Remember, no need to modify the interval as long as we're adding to an octave. We show the questions you're supposed to ask yourself and the answer in parentheses so you can see what's going on, but you can really do all this in your head. Okay, now the second example, we're adding a ninth to a fourth to a 14th. We need all intervals to be no larger than an octave, and none of them are. All the octaves are larger than an octave. All of the intervals are larger than an octave. So we decompose the intervals into a multiple of an octave plus a remainder. We don't need to worry about modifying intervals when decomposing into an octave plus some other interval, because we would not have had to modify the sum if we were adding to the octave, if you think backwards. So a ninth equals an eighth plus a second. A 14th is an eighth plus a seventh, you know. So now we gather the octaves. We have double an octave plus the remainders, you know. In order to add the second and to the seventh, we first complete the eighth from the second. That is, we ask ourselves what we need to add to the second to get an octave. We need to add a diminished seventh to the second. Remember the before last video, of course. That's what we need to do. So we need to add a diminished seventh to a second to get an octave. What will be left over in the seventh after taking that diminished seventh? A minor second will be left from the seventh. You know, remember how we learned to easily do this in the before last video. Now we can add the intervals in a way that will get us an octave plus a remainder. We get 3 times an octave plus a minor second. Remember that when adding an octave to octave, the multiples of an octave, we can pretend we don't care about chromaticism except for any modifiers already present, of course. So we get a minor second, a minor 23rd, I mean. Now we compute another example, 7th plus 6th minus 11th plus 14th. Now we have positive, we have negative, you know. We separate the positive and the negative parts, putting the positive first and the negative afterward. We treat everything within those groups as if they're positive intervals. Then we do the computation for the positives on one side and the negatives on the other. We reduce anything that is larger than an eighth to a multiple of an octave plus remainder. We can ignore the negative sign for all the positive intervals and just add them as negative ones, and then remember our negative sign afterward. We complete the eighth as usual, and we gather the octaves. We reunite everything, gather the octaves. We have to isolate an eighth to add to a remainder of a different sign, etc. And do you remember these examples we brought up in earlier videos? We can easily compute them now, armed with our new method. Here goes. We add, we add the augmented third to the diminished third, to the minor third, that's what you say, and they cancel out given the properties, and then you add 2/3. We just have 2/3 we're adding, and we use the usual system as if we don't care about chromaticism. We get 3 plus 2 equals a fifth. But remember, a strong interval plus another strong interval is either a strong interval or augmented weak. Since we got a weak interval, we have to augment the result, so the augmented third plus a minor third is equal to an augmented fifth. Okay, now for the second one. A diminished second plus a fourth equals, you just a diminished sum of a second plus a fourth. The properties. and you continue using the properties. You get a diminished 2 minus 1, which is 1, plus 4 is a diminished fifth. This is a strong plus weak. No modification is needed, for that one. That was an easy one. That was, Now for the last one, which is an augmented 50th minus a diminished 17th, So now we decompose the 17th into a multiple of, we already know that the 50th is a multiple of an octave, because 49 is divisible by 7. 49 is divisible by 7, so the octave is 50th is a multiple of an octave, We need to know what the largest multiple of an octave is, that's smaller than the 17th, in order to rewrite the 17th as a multiple of an octave, plus remainder. So we try an octave once, times 1 is equal to an octave. An octave times 2 is equal to a 15th, you see? And an octave times 3 is equal to a 22nd, so it's a 15th. What is 17th minus 15? What do you have to add to the multiple of an octave 15th to get a 17th? It's going to be equal to a 17 minus 14. You take the smallest number, remember, reduce it by 1, you get 17 minus 14 is equal to a third, just a third. So 17th is equal to 15th plus a third. So an augmented 50th minus a diminished 17th is equal to an augmented 50th minus a diminished sum of a 15th plus a third. Now you gather the octaves. The 50th and the 15th are octaves. The 50th and the 15th. There are a couple of ways to do this. You just use the properties to manipulate the diminished and the augmented symbols. To manipulate the accidental symbols, do the one you like for adding the octaves. Just use the properties and don't worry about introducing new accidentals. So an augmented 50th minus a diminished 17th is equal to an augmented 50th minus 15th plus from a diminished third, which is equal to an augmented 50th minus a 15th. Minus a diminished third, which is equal to an augmented 50 plus minus 14, which is going to be 36, minus a diminished third, which is an augmented 36th, minus a diminished third, which is a double augmented 36th minus a third. You remember the property that if you take the diminished away and you put it in front of a negative sign, and you get an augmented symbol, So you get a double augmented 34th from that, a double augmented 34th, and you remember that property, Okay, so an augmented, you could look at the properties video if you don't remember that. So an augmented 50th minus a diminished 17th is equal to a double augmented 34th. And if you want to, you could get rid of the double augmented symbol if you just want to have a neat augmented or diminish or nothing. You could rid of the double augmented symbol by rewriting the 34th as a sum of a multiple of an octave plus a remainder, which is 34th equals a 29th plus 6th. So you can easily use the properties to realize that it is a 35th, Sounds obvious, but if when you rewrote it, as you got a remainder of a third or a seventh, then applying the accidental would not be the same as for the diminished interval. As a diminished interval of the because an augmented third is not a diminished fourth, because of that, and an augmented seventh is not a diminished octave. Again, the properties video is important, for these types of things. You won't be able to do these things without knowing about the properties. Okay, and that was I can make mistakes, and I caught many calculation errors. Well, a couple. Maybe I'm exaggerating saying many calculation errors while making these videos, and point out any mistakes that you spot. And as usual, please like and subscribe, and see you next time.